has been prepared for explaining the applications of multiplexer, demultiplexer, encoder, decoder for electronics BSc students. Okay. So before we start with it, let us understand what is this multiplexer that we're talking about. Multiplexer is something which has many number of inputs and only one output. And demultiplexer is the reverse. That is, it has one input and many number of outputs. So in a multiplexer, what actually it does is, it has an n number of inputs, okay? And from these inputs, one of them will be selected and given to the output. So that means we have what is known as a selector, which selects which input has to be going. The information has to go from which input to the output. So, for example, you have a computer system or a laptop, which can be connected using USB ports to a digital camera, mobile phone charging, TV display, or wireless wired keyboard, or a Bluetooth device. So any of these devices can be connected to the computer system using USB ports. Now, at a given time, only one output is available. So from these inputs, they are all steered by means of a control line to the output. So at a time, we use only one. You can't use all of them. So this is how the multiplexer circuit is going. In this video, I am only giving you a general application and general construction working of these dividers, these circuits. In the next video, I will talk about the circuit, its implementation, and its simulation. So this is about the multiplexer. So we have 4-in-1 multiplexer. We have 3, 8, 4, 16, like that. That means if there is only one input, you have two combinations of the input lines that are available. If it is 3, it is 8, and if it is 4, it is 16. That is how we will be deciding on the number of inputs. Then we will be talking about these selection lines. So if you have two inputs, you can have 4 selection lines as 0, 0, 0, 1, 1, 0, and 1, 1. 0, 1, 2, 3. That means whatever devices you are connecting, you can connect it to any of these. It is like, giving a unique ID, a unique number to these devices. How will a system identify? It's all binary. It's all in a machine language. It will not understand if you say printer, a camera, and so on. Each of these devices are connected through USB port, and a unique address is given, and that address will be decoded later. So you assign an address of 00, so let us say for a printer, 1 for a camera, 3 for let us say a keyboard, 4 for mobile device. Then if your coding is 00, it will select a device connected to 00. If it is 01, it will select a device connected to 1. 10, device connected to 2. 11, a device connected to 3. So the information will be transferred towards the output. This is how it will be working. So how do you decide the output as 00? That means it is S0 is 0, S1 is also 0. You will represent this as S0 bar dot S1 bar. Then S1 is high and S0 is low. So 0, 1, how do you write it as S1 S0 dot? 1, 0, S1 S0 dot. 1, 1, S1 S0. This is how you represent a Boolean expression. So this is how a multiplexer is working. Now let us see a demultiplexer. A demultiplexer is the reverse. That means one to be many. One to many devices. The previous multiplexer was called as a selector. Now you call this as a router. It's like your Wi-Fi router, which you are all familiar with. You are all using at homes. So you must be using a D-Link, Netgear, or any other router. To the router, when you see, just check on your boxes at home. When you see a router, it has 4 ports. One is called the main port. The remaining one are all parallel ports. So when you are a service provider, you can take connection from ActFiber, Hathway, Geo, whoever is your service provider. that input line will come directly to the main port. That is little broader. Then remaining, you can have 4 ports, you can have 16 ports, 24 ports, 48 ports, depending on the organization. Generally, for domestic purposes, for home, we'll be using only 4 ports maximum. So one port is main. The 3 ports can be connected to a laptop, a smart TV, or a mobile. So each of them will have a different IP address. As what I told you is address, in terms of internet, it is an internet protocol address. So our router is the one which gives these designated addresses to the devices automatically, or you can even customize, and the information, the traffic will be diverted. This is as simple as you are managing traffic on the road. What do you do normally when there is a traffic congestion in one road? The traffic police will take you, divert you to the sublines. Same way here also it is into the traffic. So it is basically done by demultiplexing. In your computer systems also, you can have, let's say you have a lab, you have a different printers available there, a color printer, a black and white printer, a scanner, a fax machine, something else. So suppose you have all these things connected to a single laptop system, then you can take a printer. When you just say print command when you give, go to Alt F and print, you will find enumerated a list of printers that are available. If you want a color printer, you must type or select from the drop down menu that particular printer and give a command so that you get a color printer. If you want black and white, you should choose it from the list which is given there, the black and white, and you get a black and white. Same way, if you want to use it for scanning or faxing, appropriate selection has to be done. That will be routed by this. So this is how our router is working. That's nothing but a demultiplexer. In communication systems, lot of applications are there for multiplexing and demultiplexing. Another example what I can give you is your cable TV operators. They are giving you every month you are paying some subscription or quarterly subscription either to a cable TV or to your DTH or Tata Sky. Whatever be it is, they are all connected to a satellite. This is through satellite communication that we are getting this information, the TV, the video signals. So each operator is allotted a particular frequency range. You are supposed to work only in that range. In that range, whatever maximum number of channels can be transmitted, it will be transmitted. So your cable operator is a router there. He is only one, but he is catering to all the houses in that neighboring area. This is how a demultiplexing works. Then coding and encoding. Coding and encoding is generally dealt with in a subject called as cryptography in digital communication. So before we go into those details of digital communication, let us try to understand what basically is encoding and decoding. Encoding is to code, decoding is to decode. Now how do you encode? One familiar example is BCD to binary, BCD to decimal, decimal to binary. Forward, reverse. One is coding, the other is encoding. So to encode the decimal numbers, which are 10 in number, you make use of the BCD input lines. Let us name them as A, B, C, D. And these 4 lines can generate how many numbers? 10 decimal numbers you can generate. So A, B, C, D, A is your MSB, the most significant bit, and D is your least significant bit. A, B, C, D, 0, 0, 0 will be generating a digit 0. 0, 0, 1, 1, 0, 0, 1, 0 is 2, 0, 0, 1, 1 is 3, 0, 1, 0, 0 is 4, 0, 1, 0, 1 is 5, 0, 1, 1, 0 is 6, 0, 1, 1, 1 is 7, 1, 0, 0 is 8, 1, 0, 0, 1 is 9. So when you want to generate a code for a particular digit, you have to draw a circuit, construct the circuit to generate this. So if you want that means a particular digit is coded like this in this particular format. Suppose you want to code the number 8. What is 8? And you want it to be displayed at the output. In your 7-segment display center, you have these numbers displayed. How do you think that this is happening? You have decoders, you have drivers to drive these. So 1, 0, 0, 0, suppose you are doing 8. A should be high, all the remaining should be low. How is it done? Normally, we use AND gates. When you use AND gates, the output is always high when all the inputs are high. So what you do for this 1000, you give A as high, give B, C, D through an inverter and give a 0 signal. 0 after inversion becomes 1. So all these zeros will become 1. Finally, the inputs to the AND gate is 1. The output is going to be 1. So when a digit, that means it is detecting when the digit 9 comes, or when the digit 8 comes. So that is decoding. You are encoding it as 1000. You are reading it using a device, that is decoding. So this is a general application that I am talking about, these coding and encoding. We will do in the next video what the circuits are, how this is working. Okay.